start the recording and then we continue the final review. Finish the test. Let's see where we were on Monday. We finished question 16, so we're on number 17. Or number 17. We did number 17, didn't we? Didn't I save it? Oh no, I did not save it. That sucks. So anyway, I'll just skip it, all right? I'll just go start from 18, question number 18. Question number 18, for the equation, answer parts A and B. A is to state the x and the y intercepts. B is to use the intercepts to graph the line. All right, so I'm going to find the intercepts on my OneNote. The rule for finding intercepts, I hope you can memorize. Firstly, you need to know the definition of x-intercept and y-intercept, right? What is x-intercept? What is y-intercept? X-intercept is the intersection of the straight line and the x-axis. So the intersection is the point where the straight line crosses the x-axis. Hi, Kaylin. Joe, I'm on my iPad. Let me read this. I may lose power. I thought I had enough, but I don't. I may lose you. It's okay. Just watch the recording later. Kaylin said, "Am I the only one who, hold on, just sees the main TCC page and no math on her end? I'm not sharing now. Hold on. Probably my bad. My bad. I didn't share successfully. Oh, I think I shared it wrong. Let me reshare it. Let me see, how do I get it done? How do I fix this? So, okay, now should fix. I apologize. I did not properly share the screen. Yeah, awesome. Sorry about that. And y-intercept is the intersection of the straight line and the y-axis. We know x-axis is the horizontal scale and y-axis is the vertical scale of the rectangular coordinate system. So that's the definition. You would have to know the definition. And then you also need to memorize and understand the rule for finding x-intercept and y-intercept. To find the x-intercept, make y be 0. So here we have negative ay equals 2 plus x. To find the x-intercept, make y be 0. To find the x-intercept, make y be 0. Make y be 0 means this term is going to disappear, right? Because negative 8 times 0 is going to be 0. And we have 0 equals 2 plus x. And this gives us x has to be negative 2. Only the two numbers, they are opposites of each other. They add up to 0. So x here has to be negative 2. So the x-intercept is negative 2 comma 0. And to find the y-intercept, we make x be 0. Make x be 0. Then we have negative 8y equals 2. and divide each side by -8. Cancel, cancel, and then y equals 2 over -8, that is a -1/4. So the y-intercept is 0, comma, -1 over 4. All right, so that's the two, those are the two intercepts. Very good. Perfect. And let's see one more time, and then we are going to graph it. -2, comma, 0. I need to make this bigger. Actually, I need to click here. Oh, I need to enter the intercepts first. Very important. Read the information in the parentheses. It says type an ordered pair. Then you have to type an ordered pair, not just a number. X-intercept is -2, comma, 0. -2, comma, here, 0. And the y-intercept also type an ordered pair, not just one number. Has to be a pair with two components. And don't mess up the order. X-intercept have y value equals 0. Y-intercept has x component equals 0. And y is a -1 over 4, right? Let me double check. Yeah, -1 over 4. So we have a negative, let me hide this, 1 over 4. And we have those two intercepts found, and we are going to use the two intercepts to graph the so tiny. Let's see, can I make it bigger? Click the graph, choose a tool in the palette, and follow the instruction. Okay, so I'll just stress my eyes for this. Use this, and 92, comma, 0. This is a 0, this 91, this 92, 92, comma, 0, and then 0, comma, -1 over 4. That's gonna be challenging for me. This is 91, 2, 1, 2, 2, 3, 4, 1, 2, 1, 2, 3, 4. One, two, yeah. Oh, hold on. 1, 2, 3, 4. Yeah. All right. That's it. This is bigger. Oh, you know what? You can try this and then make it bigger to double check. Now I can see the better. So yeah, I did it wrong. This is not okay. I can change it here. Oh, okay, this is better. 92, comma, 0. This is 92, comma, 0. And this is 0, comma, 1, 2, 3, 4. 1, 2, 3. Hold on. No. 1, 2, 3, 4. 1, 2, 3, 4. Oh, that's correct. Now it's correct. Now it's correct. I'm sure about that. So that's that question. Next is similar. Graph the equation. Be sure to simplify the equation before graphing it. Well, if you need to graph a vertical or horizontal straight line, that actually is a easier problem. If you know the corresponding equation, what equation represents horizontal straight line? What type of equation represents vertical straight line? So let's simplify. For this equation, we could do this. We keep 9x on the left side and then move 3x over, 93x, and then move 6 over, -6. 9x minus 3x, 6x. 6x equals 96. and then divide each side by 6. We have the x equals -1. So after we simplify, the equation becomes x equals -1. Okay, please type in the chat. Does this equation represent a vertical straight line or a horizontal straight line? Vertical. Thank you, Jacob. Very good. Thank you, Amanda. That's correct. It is a vertical straight line. Okay, let's remember the vertical straight line happens at -1, at x equals -1. So let's graph it. It's going to be actually easier. X equals, this is a 0, this is -2, so between 0 and -2, -1, and you just go up or go down to click another point to make sure the straight line is vertical. That would be fine. And you can zoom in, like make it bigger to double check your result. This is x equals -1, so that's correct. Next, find the slope and the y-intercept. Slope and the y-intercept. If the equation is in the slope-intercept form, then identifying slope and the y-intercept would be very convenient, right? However, this equation is given in a standard form. If we could rewrite the equation in the standard in the slope-intercept form, then we can answer the slope and the y-intercept pretty quickly. So let's do that. That's the plan. The equation is in the standard form. We are going to rewrite the equation in the slope-intercept form. Slope-intercept form looks like this: y equals mx plus b. On the left side of the equation, variable y is isolated by itself. So we are going to solve 7x minus 2y equals 1 for y. Okay, for y. And firstly, we solve for y means we are going to treat x as a constant, even it's not. So we are going to keep -2y on the left side, and then 1 on the right side, and then we are going to move 7x over to the right. And 7x changes side, and the sign is going to change as well. So 7x on the left is positive, it's going to be negative on the right. So now we have -2y equals -7x plus 1. And then we divide everything by -2. Divide by -2, divide by -2, divide by -2. 2 cancel 2, we have a y on the left side equals 7 over 2 is a positive 7 over 2x. 1 over 2 is a negative 1/2. So now the equation is in a slope-intercept form. And we have the slope 7 over 2. And we have the y-intercept 0, negative half. All right, so let me remember that. Slope is 7 over 2. Let me type it first. Simplify your answer. 7 over 2 is a simplified fraction. 7 over 2. Y-intercept. Read the sentence in the parentheses. Type an ordered pair. Simplify your answer. So if you only type in -1/2, and you get it wrong, you have to type in a pair, ordered number pair. So it's going to be 0, -1/2, -1 over 2, -1 over 2, 7 over 2. Yeah, that's correct. Make sure always double check your answer. It does worth your time. Next, find an equation. Let me copy paste, then I can see it better. It's very tiny. Make it bigger. Find an equation of the line that has the given slope and passes through the given point. The equation of the line is, type your answer in slope-intercept form. So our goal is to write the equation in the slope-intercept form. The formula again is y equals mx plus b. So we know the slope is already 3. So the equation is just going to be y equals m is 3, so 3x plus b. All we need to find is the value of b. How do we find the value of b? We have one more piece of information. The equation has a solution, -4, 0. It says -4, 0 is a point on the straight line. Algebraically speaking, that means -4, 0 is a solution of the equation. And that means -4, 0 satisfy the equation. So when we plug x equals 94, y equals 0 into the equation, we should have a true statement. Y is 0, x is a -4, 3 times -4 plus b, and 0 equals 3 times -4 is -12 plus b, and b has to be +12. B has to be +12 in order for the left side be 0. -12 plus 12 is 0. So the equation is going to be y equals 3x plus 12. Also, we can spend just a few seconds to double check our answer. Slope is 3, so this satisfies. And the -4, if you plug in here, double check, 3 times -4 is -12, -12 plus 12 is 0, -4, 0 satisfies the equation. So that means this equation is correct. You don't have to wait for the system to tell you if it's correct or not. I really don't think this is challenging, but it does take a certain level of algebraic ability. So the answer is y equals 3x plus 12. Y equals, type the whole equation. Y equals, is that capital letter? No. Y equals 3x plus 12. Double check. 3x plus 12. Okay, next. Write an equation of the line in the figure below. I need to make it bigger. Where? Oh, it's right here. The equation. Even if it's tiny, in the sentences in the parentheses, we need to read them. It says simplify your answer. Type your answer in slope-intercept form. So that is important. Use integers or fractions for any numbers in the equation. So it means you do not use decimals. Okay, so since it's a slope-intercept form, I want to find my slope and the y-intercept. I have the y-intercept already. The y-intercept is 0, -1. All right, so b equals -1. And then I'm going to see how do I find the slope. Yeah, let me copy paste. I'm going to show you how do we find the rise over run from the graph. Slope is rise over run. And we are going to consider the two red dots. I'm going to label, just for convenience, label this dot as A, this dot as B, and we are going from A to B. Go from A to B, let's count how much is the rise, how many is the run, positive or negative, all right? So I'm going to construct a right angle triangle like that. You can do that, or you can do this way. Some of my students like this way because it can use one of the axes, y-axis. So as you can see, from A to B, rise is 2 units. Yeah, you also have to check the grades. One is 1 unit. It is 1 unit from 6 to 7 to 8 to 9, right? It is 1 unit. So as you can see, the rise is 2. 2 units. The run is 3. 1, 2, right? Rise is 2. Run is 1, 2, 3. So it's 3. So the slope is 2 over 3. Y-intercept is 0, -1. As you can see right here, this red dot. So B value is -1. So the equation in the slope-intercept form is going to be y equals 2/3 x minus 1. You're going to type exactly this in the cell. Y equals 2/3, use this, 2 over 3 x minus 1. 2/3 x minus 1. Okay, very good. Next, let me copy paste. Actually, let me see. Yeah, let me copy paste, and then we graph it. So this is an inequality, linear inequality in 2 variables. We're going to find a region in the rectangular coordinate system that represents the solution set of this inequality. You might remember the solution of this type of problem has 2 parts. The first part is to change the inequality symbol to equal sign. Everything else stays the same. So 3x equals -4y. And what is that? Is the boundary line of the region we are looking for. The region represents the solution set of the inequality. Okay, let's see how do we graph 3x equals -4y. So firstly, I would switch the left side and the right side because I want to find the equation in the slope-intercept form. So y variable is on the left side. So firstly, let me switch the side. -4y equals 3x. What I do is like a scale. If you switch, like you turn it, rotate it, and left side become right side become left side, it's still in the balance. It's still in balance. And then I'm dividing each side by 94. By 94, cancel, we have y equals -3/4 x. So that means the equation has a slope -3/4, has a y-intercept 0, 0. When you plug in x equals 0, y is 0, right? Well, you can use the slope-intercept to graph the line. Or, you don't have to. You can be flexible, right? All it takes to graph a straight line are 2 different points. We already have a point. We only need another point. Another point, how about we let x be 4? Why do I decide to let x be 4? Because the denominator is a 4. So if I let x be 4, it cancels the denominator 4. And 4, -3. 4, -3. So this would work. And it's easier than you rise and run. Well, depends on your preference. Rise and run is also a good method. Or you just plug in a value and to find another point. So here I plug in 4. 4 cancel the denominator 4, and the y value is -3. So 4, -3. So I'm going to use the 2 points here, 4, -3 and 0, 0 to graph the line, the boundary line. Are we going to graph the boundary line solid or dashed? What's the reason we need to graph it as a solid? Because the original inequality symbol, is less than or equal to. Solid, perfect. Thank you, Amanda. Exactly. So let's graph it. We're going to graph a solid line. solid straight line passing through 0, 0 and 4, 93. 4, 93 is in quadrant 4. 4, -3. Is that there? Let me look at it closer. That's 0, 0. So 1, 2, 3, 4. Go down 1, 2, 3. Yeah, 4, 93. Let me double check. Yeah, 4, 93. So that's the line. That's the boundary line. We are not done yet. We need to determine which side of the boundary line describes the solution set of the inequality. So we are going to find out. So let's do that here. So we have 0, 0, 1, 2, 3, 4, 1, 2, 3, and this is the boundary line. And we need to find a testing point to determine this is the original inequality. Once we have our boundary line graphed, we are done with the equation. We need to go back to the original inequality. In this case, 0, 0 doesn't work anymore because 0, 0 is on the boundary. It's on the fence. Cannot be used to decide which region is the solution set, right? So we are going to pick another point. I'm going to pick 1, 0 here. 1, 0, just for convenience. I'm going to plug in x equals 1, y equals 0. And I have 3 on the left side, 0 on the right side. 3 is less than or equal to 0 is a false statement. So it's not true. That means the region we're looking for does not contain 1, 0. Does not contain the testing point. So we have to shade the region below the boundary line. So we're going to shade the region below the boundary line. I'm going to use this to click here, and that's it. You can make it bigger and then double check your result, right? Because 1, 0, it doesn't satisfy and it should not be in the yellow region. It has to be in the white region. Everything looks good. 0, 0, 4, 93. Okay. Next, multiply. Leave your answer in exponent form. So read the question. Do not just, okay, I have a scientific calculator. Let me see what's the value. While you do extra and you got it wrong, you don't get a point because the system tells you specifically, clearly, leave the answer as an exponential expression. Use the positive exponents only. This is also important. Obviously, we are multiplying two powers with the same base. You might remember the rule I have in the class worksheet. For each rule, I give you a Q, right? When we multiply two exponential expressions with the same base, we keep the base, which is 6, and add up the exponent. The first exponent is 13, second exponent is 15. 13 plus 15 is 28. And that's it. Really not challenging. This is the basic thing. And this one obviously is to use quotient rule, right? Simplify your answer. Use integers or fractions for any numbers in the expression. Type exponential notation with the positive exponents. So we are dividing two exponential expressions with the same base. So the Q is keep the base and use the exponent in the top to minus the exponent in the denominator. So 12 minus 24 is a negative 12. But we do not leave a negative exponent. So we have to use 1 to over, take the reciprocal. 1 over, oops. So you have to use this, enter that first, the structure setup. And 1 over 16 to to the power of 12. Think about numerator is 16 to the power of 12. That means the numerator has 12 16ths multiplied together, like 16 times 16 times 16 and so on and so on times 16. You have 12 16ths on the top, and you have 24 16ths on the bottom, twice of the numbers. So half of them is cancelled. So numerator becomes 1, denominator only have 12 16ths left, and that is 16 to the power 12. And this is also a very basic problem, not challenging at all. I guarantee you, if you know those basic things, don't worry about those challenging. You don't have to get 100 on the test to pass the course, right? I do strongly recommend you to get 100 on those homework assignments, even quizzes. Homework assignments, you have unlimited attempts. There's no reason you do not get 100%, right? It's completely in your control. And even quizzes only give you 3 attempts, but I think you have more than you need. Technically, 2 attempts would be enough. The first attempt you try, and then you figure out which question you don't know, and you figure it out. And then you try the second time, your score should be a lot better, right? Improved better. So the test is challenging because the closed book, closed note, and is just 1 attempt. But you don't need to get 100% on the test. You only need to get actually 50%. You'll be safe in the class. Of course, you aim higher, like you aim to 70%, aim 70%. And there are challenging problems in the test. I admit that, but you don't have to worry about those challenging problems. If you take a good care of those basic problems, you can get a 70% at least, I believe. Okay, so let's continue. Simplify. I'm going to just do it here. Okay. So first, let's set up the structure. Numerator is gonna be 4x to the power of 2, and 4 to the power of 2 is 16, and then x to the power of 2, x to the power of 2, right? Because the numerator is the square of 4x. Square of 4x means 4x times 4x. And 4 times 4 is 16, x times x, x squared. That part is fine, right? Even this question is a little bit more complicated, but you break it down, and each piece is still very straightforward. And the denominator, we're going to have a 7y to the power of 4 and then to the power of 2. So that means 7y to the power of 4 times another 7y to the power of 4. So you're going to have 2 7s multiplied together. 7 times 7 is 49. And you have a y to the power of 4 and times y to the power of 4, you have y to the power of 8. Like that. 49 y to the power of 8. And let me show you, if you really don't get it, you do this, okay? If even you don't know those rules, as long as you know the definition of exponential expressions, you can get it done correctly. So this is a square, so it means base times base, right? So 4x over 7y to the power 4 times itself. And we can remove the 2 parentheses and then multiply across. Numerator is 4x times 4x. Denominator is 7y4 times 7y4. And numerator is just 4 times 4 is 16, right? X times x is x squared. And denominator, 7y4 is y. And 7 times y. So that gives me 16x squared. Denominator 7 times 7, 49. 1, 2, 3, 4, 1, 2, 3, 4. You have 8y. All right. So as long as you know the definition of exponential expression, you still can do the problem. If you don't know what is the exponential expression, then I cannot help you, because you're supposed to know the most basic thing. Then you should not pass. Next. Okay, simplify, assume the variable c is non-zero. Okay, so we're going to use power of a product first. 3 to the power of -3, so that is 1 over 27. Yeah. Use positive exponents only. Use integers or fractions for any numbers in the expression. Simplify your answer. So I'm going to use this, and I have 27 on the bottom. And the numerator is going to be c to the power 9, because 93 times 93 is a positive 9. C to the power of 9. C to the power of 9. Okay, let me show you how do you get it done. How do you figure it out? Explain in my OneNote. Well, this one is a little bit challenging because it has a negative exponents, right? Well, you do need to remember the negative exponent, -1 exponent is equivalent to taking the reciprocal, right? Okay, so I'm gonna use power of product. It is a basic rule that we have learned. Power of a product equals product of powers. Those are basic. Otherwise, what do we learn? Is this that's what we learn. So this is yellow times blue. The base is a product, so we are looking at a power of a product. By the rule, we have the power of a product equals the product of powers. So 3 to the power of -3 times c to the power of -3. So yellow to the power of -3 times blue to the power of -3, right? So you do have to know that. And then we have a 3 to the power of -3, and then use the power rule. Power rule, remember, we use power rule to simplify a kangaroo structure, right? And you have a baby kangaroo inside a mother kangaroo. So you're gonna have the one base and the two exponents. You're gonna keep the base c and then multiply the two exponents. 93 times 93 is a positive 9. And how do we know 3 to the power of 3 equals 1 over 27? I'm not sure if your scientific calculator could help you. If it does, figure it out. And 3 to the power of 93 is 1 over 3 to the power of 3. And that is 1 over 27. So 27 is on the bottom, c to the power of 9 is on the top. Well, this one is challenging. Even I say they are basic, to be honest, they are basic, those things. It is a little bit challenging. Then how do you make it not challenging? You practice. When you repeat the same problem like 10 times, mindfully, not like a copy machine. Mindfully copy or repeat the problem 10 times, even 20 times, you will feel different, I promise you. The first time you figure it out and to mimic like whatever the teacher does in a class, it might be difficult and take you a long time. But if you repeat the same process multiple times and figure out the reasoning for each step, and the question will become a lot of like so clear, so easy, so straightforward to you. And then when you see similar problem later, you would know how to do that. Remind me later. Okay. So next, write the number in decimal notation. Decimal notation. Okay. So you have a calculator, right? This is what you do if you go from scientific notation to decimal notation. This is what we do. 5.1 times 10 to the power of 96 is 1 over 10 to the power of 6. So basically you are multiplying by 1 over 10 to the power of 6. And that is the same with 5.1 divided by 10 to the power of 6. 10 to the power 6 is a million. 1, 2, 3, 1, 2, 3. So you can use your calculator to divide use a calculator to divide 5.1 by a million, and you get a decimal. Or if you understand the notation, scientific notation, you know this scientific notation represents a tiny decimal. And -6 power means we need to move the decimal point to the left 6 times, 6 places. So we have 0.1, 2, 3, 4, 5, 5, 1, and then double check. I have 5 zeros in front of 5 behind the decimal point. So 1, 2, 3, 4, 5, 6. Yeah, that's correct. Be careful. If you miss 1 0 or you have 1 extra 0, miscount the zeros, then you get it wrong. Next up, state the degree of the polynomial and whether it is a monomial, a binomial, or a trinomial. This obviously is a trinomial, right? Trinomial. And what's the degree of the polynomial? What's the biggest exponent on the shoulder of x? 9. So degree is 9. Yeah, that's it. Oh, be careful. Trinomial. All right, very straightforward. This type of problem is that you should not lose a point on. This is a definition of polynomial. Use the formula for a binomial squared to multiply. Okay, so let's see, how do we do that? This is a special product, but you do not have to know special product. You only need to know how to multiply polynomials. Specifically, in this case, how to multiply two binomials. So you have a square of 5x minus 4. That is 5x minus 4 times 5x minus 4. 2 by 2 box. And I'm going to write 5x minus 4 here and 5x minus 4 here. And then let's multiply. Row 1, column 1, 5x times 5x, 25x squared. Row 1, column 2, 5x times -4. If you are not sure, you tend to make a mistake doing that in your head. You don't need to do that in your head. Write it down on your scratch paper. 5x times -4, -20x. 5 times positive times net is negative, right? 5 times 4 is 20, and then x. -20x. Row 2, column 1, -4 times 5x. So also -20x. And then row 2, column 2, -4 times -4, positive 16. And then the diagonal, the two cells in the diagonal, they are like terms. Combine them. And we have 25x squared minus 40. Combine them, -20 minus 20, -40x plus 16. And then you enter that in the cell. This is a basic as well. Box method to multiply two polynomials. This is very basic. You should not lose a point on this type of problem. So we have 25x squared minus 40x minus 40x plus 16. 25x squared minus 40x plus 16. Okay. Next. This is to divide. Okay, let me copy paste. Read the instruction. If you don't read it, to me it looks like a minus, but if you look closer, it's divide. Also because it says divide here. Make it bigger. Divide. And we're dividing a trinomial by a monomial. This is a divisor. This is the dividend. When the divisor is a monomial, we do not need to use long division. we have a better method, right? And I think this is basic. 15x to the power 8 minus 27x to the power 4 plus 18x cubed divided by. So we're gonna write the division expression as a quotient all over 3x cubed. And you remember how to do this, right? We're gonna use each single term in the numerator to divide by the denominator. So term 1 on the top over the bottom plus, be careful with the sign, term 2 on the top over the bottom plus, term 3 on the top over the bottom. Have this on your scratch paper and then simplify in the next step. Don't rush. 15 over 3, 5. X to the power 8 over x to the power 3, x to the power 5. Negative over positive, second term is negative. 27 divided by 3, 9. X to the power 4 over x to the power 3, x. And the third term is a positive. 18 over 3 is a 6. X cubed will cancel x cubed. So this is the answer we're going to enter. And this is a basic. You should get this correct. So think about, we have 40 questions, right? We definitely have more than half questions are basic questions. You should not get a lower than 50%. Of course, the higher the better, especially when you have lower score from previous exams. So here we have 5x to the power of 5. Let me double check. 5x to the power 5, yeah, minus 9x plus 6 here. Next, this one is remove the GCF. Check your answer by multiplication. Okay, so this is to factor, and not just a factor completely. Factor completely. We have 4 terms, but don't rush. Look for GCF first, and look at the numerical part. 3757, all prime. Of course, no GCF is 1. And then look at x. X does not appear in all the 4 terms, so x is not going to be part of the GCF. And then we look at the y. Y appears in all the 4 terms, so y is going to be in the GCF. In fact, y is the GCF. Okay, y is the GCF. And in the parentheses, we're going to have 3x, y, because you factor one y out, you have another y left. And minus 7a plus 5x. Minus 7a plus 5x and minus 7. All right. Let me see. Can we continue to factor this polynomial by grouping? We can't. You would just leave that like that. Yeah, I agree, Amanda. So that's gonna be just the answer. The thing is, how do you know you don't? I think if you go to exam, let's see the pattern, all the questions we see so far. If it asks you to factor in by grouping, then definitely you use the grouping method. If you look at the 4 terms, because you look at them, this part has a. Only one term has a, letter A. It's not gonna work, you know. we will not have like a when you group and factor out GCF, they have the same binomial factor. It's not gonna happen. So if you see something like that, you just leave like this. Oops, what happened? I just need it. Okay, let me just type the answer here. We're gonna factor y out and the parentheses, left-handed parentheses, we have 3xy minus 3xy minus 7a plus 5x minus 7. Close the parentheses and double check. Y is out, 3xy minus 7a plus 5y minus 7. Okay, that's correct. Next. Factor. Oh, let's do this one. Factor completely. Whatever the method works for you, guys. I recommend my method, but if you have your original method or the new method you learn, you like it, then you can just use those methods. Let's see this problem. 18x squared minus 39x plus 18. Firstly, I think the three numbers too big. I don't like it. Then I want to know if they have GCF that I can figure it out to make the numbers smaller. I notice 18 is divisible by 3, 39 is divisible by 3, 18, the second 18 also divisible by 3. So I think that GCF is 3. Yeah. So we firstly factor 3 out. And in the parentheses, we have 6x squared minus 13x plus 6. You know what? This problem, this trinomial is on my worksheet, class worksheet. And we at least did twice of this problem in the class. So let's continue factor the trinomial in the parentheses. And we are going to use slide divide slide method. Slide, create a new x squared minus 13x plus 36. And shortcut, the two numbers are going to be 94, 99. Okay, why? Because 36, because we're looking for two numbers. I feel like if I keep a count, keep track how many times we have been doing shortcut. How many times we have been doing shortcut? Over 100 times probably, right? Just estimate. So we're looking for two numbers, multiply to 36, add up to negative 13. And the two numbers must be both negative because they have to have the same sign in order for the product to be positive. And they cannot be both positive because they add up to negative. And we try 36. It is 1 times 36, 2 times 18, 3 times 12, 4 times 9, and you see, oh, 4 times 9, 94, 99, right? You don't even have to continue, finish. And then you divide the two red number by the original leading coefficient. And you have x minus 4 over 6 reduced 2/3. 9 over 6 reduced 3 over 2. Rewrite this 3. And then move this back. Slide this back. So the answer is going to be 3x minus 2 times 2x minus 3. And then put it back. 3 times 3x minus 2, 2x minus 3. This question, I would say medium difficulty level of difficulty medium. But Since we have this problem on the worksheet, I would say this is a easy problem. Let me type the answer. We have 3 times parentheses times parentheses. And we have 3x times 3x minus 2 multiplied by 2x minus 3. So I understand everybody is busy. I'm busy too. So you only have limited time. Everybody only have 24 hours, right? How do you study smart? And you're gonna treat my worksheet, class worksheet seriously, right? Because you already spend 4 hours every week to study those problems, those basic problems, important methods. You already spend 4 hours. Why not just spend more time to really get familiar with those problems, those methods? Once you get that foundation built up, and then you work on the Pearson problem, and you will feel better. Not just, okay, all I need to do is to do Pearson. Well, you don't even remember or understand probably what I say about in the class, right? Then you just you kind of like you waste the 4 hours every week. That's just my suggestion. 3 times 3x minus 2, 2x minus 3. Okay. Next. Factor by, okay, I don't use that method. We just need to factor it, right? Let's factor it. This is a quadratic trinomial. GCF is 1. 3 is prime, 7 is prime, 20 is not divisible by any 3 word divided by 7. So this is gonna be a slide divided slide application. We practice this problem. We practice this method also many times. Slide. Shortcut. Let's see. We need to find the two integers multiplied to -21, add up to -20. The two numbers must be one positive, one negative, and negative number has a bigger absolute value. And let's see which two numbers. 21 can be written as 1 times 21 or 3 times 7, and that's it. And the bigger number, negative number has bigger absolute value, so we place negative sign on top of the second factor, and it's a positive. And this is the case. Positive 1, negative 21. Double check. They do multiply to -21, add up to -20. And then divide the two red number by the original leading coefficient 3. And let's reduce. X plus 1/3, 1 over 3 cannot be reduced. And then x minus 7, that one can. 21 divided by 3 is 7. And when you still have denominator, slide it back. So what our answer is going to be 3x plus 1 times x minus 7. 3x plus 1 times x minus 7. 3x plus 1 times x minus 7. Double check again, 3x plus 1. Yeah, that's correct. Next. Factor by using the perfect square trinomial formula. Well, if the question specifically tell you that, we will make it a lot easier. If the question specifically tell you to use the formula, that means it is a perfect square trinomial. And all you need to do is to find the two bases. So this is going to be a perfect square. Let's see what's the base. 4x squared, 2 times 2, 4 is 2 times 2. X squared is x times x. So I have 2x times 2x, and it's 2x to the power 2. So the first base 1, is 2x. And from here, we need to find the second base. 25 is 5 squared. So the second base is 25, is 5, is 5. So your answer is going to be, knowing the middle term is a positive, okay? Knowing the middle term is positive. So your answer is going to be the first base plus the second base. The reason is plus is because you have a positive sign here. And then to the power 2. All right? Because the question specifically asks you to use the formula, that means this is a perfect square trinomial. We don't even have to double check. I promise you, there's no question will trick you. I ask you to use the formula and it turns out it's not a perfect square trinomial. It has to be. So all you need to do is to analyze term 1 to find the first base, analyze term 3 to find the second base, and then add up the two bases, and then raise the parentheses to the power 2. I think you can do this. Do parentheses and raise the parentheses to the power 2. In the parentheses, you have the first base, 2x, plus second base, 5. And that's it. Right? I think it's pretty straightforward. Next, let me copy paste. If in the future you learn probability, you would learn a very important rule for a theorem. Frequency approaches to probability when n approaches infinity. What does that mean? Means if when you practice, the same type of a question appears over and over and over again, and you see this type of question so many times, and that means what? Means you're going to see the same type of question on the test. And this one says use the formula, and you're going to use the formula. All right, we don't have to check the middle term. I promise you this is going to be a perfect square trinomial. The formula we're going to apply is the same formula with the previous problem, like this one. All right, so from the first term, 25a squared, let's figure out what's the first base. 25 is 5 times 5, a squared is 8 times 8. So 5a times 5a, it is 5a to the power 2. The first base is 5a. And then we try to figure out the second base. The last term, 64b squared. 64 is 8 times 8. b squared, b times b. 8b times 8b, so it's 8b to the power 2. So the second base number 2, is 8b. You got your first base, you got your second base, add them up to the power 2, right? 5b plus 8b, 5a plus 8b. So type of parentheses to the power of 2. In the parentheses, 5a plus 8b. 5a plus 8b. 5a plus 8b. Okay. It doesn't hurt, never hurt, doesn't hurt if you triple check. Okay, very good. Next. Factor. Okay, let me copy paste. Well, this is a binomial, right? And it's a binomial in the middle. is a minus sign, and you see x squared, y squared, 49, which is 7 squared, 81, which is 9 squared. That is a strong sign this is going to be a difference of 2 squared. Let me write down the formula. And you should write down the formula on your scratch paper. Right? Okay, let's see. 49 x squared minus 81 y squared. 49 is 7 squared, 81 is 9 squared. So we can write this, the first term as 7x in the parentheses and then to the power 2. This one is 9y to the power 2. First base 7x. Second base 9y. So your answer is going to be parentheses times parentheses. In the first parentheses, you have the first base minus second base. Second parentheses, you have first base plus second base. And that's it. I would say this is a pretty straightforward problem, not challenging. Let's enter that in the sum. Oh, okay. You have to choose this first, and then in the sum. Parentheses, 7x minus 9y. And then in the second parentheses, 7x plus 9y. And double check. 7x minus 9y, 7x plus 9y. Next. Remove the GCF, then continue to factor if possible. So very busy, right? So I would consider GCF for sure. 33, 6. Numerical part, GCF is 3. Variable part, x, and that's it. Y does not appear in all the 3 terms, so y is not going to be part of the GCF. So it's just a 3x. So we're going to factor 3x out. In the parentheses, we have 10x squared. Well, let me show you how do we figure that out. The method we learned from the class. Term 1 over GCF plus term 2 over GCF plus term 3, which is negative, over GCF. And simplify in the next step. We have 3x outside. Inside we have 10x squared, right? X cubed over x plus xy. 3 cancels 3. X squared over x is xy. And minus 2y squared. Minus 2y squared. Minus 2y squared. 20, yeah. We would have to factor this trinomial by using shortcut. By using slide divide slide, I'm sorry. So let's make it easier. I know what make the trinomial difficult to factor is because it has 2 variables, right? So I would do this. I would get rid of y for now. Let's get rid of y for now. Remove, like kick y out or remove y for now. And later we're going to bring it back, okay? So we're going to have a 10x squared plus x minus 2. And I think you know how to factor this one, right? It's going to be a simple slide divide slide application. Slide. Shortcut Negative 4 times 5, negative 20. Negative 4 plus 5, positive 1. And then divide original leading coefficient 10. Simplify the fraction. This is a negative 25. This is 1/2. And then slide it back. And we have 5x minus 2, 2x plus 1. And then now we're going to bring y back. Bring y back. And we are going to, this is a constant 2, right? Times y. Put y here. And 2x plus 1, 1y. And then we're going to bring the back. And the final result is going to be 3x times 5x minus 2y times 2x plus y. If you are not sure, we can use the box method to double check our result. I mean this part, right? We can try 5x minus 2y, 2x plus y. And this is 10x squared. This is 5xy. This is negative 4xy. This is negative 2y squared. So I have 10x squared, this like terms, plus xy minus 2y squared. It's the same with the trinomial in the parentheses. So I give you a trick that you don't have to worry about the two variables. You can remove y and then do the slide divide slide and then bring y back. 5x minus 2y, 2x plus 1. Okay, let me enter 3x on the outside. And then we're going to have parentheses times parentheses. In the first parentheses, we have 5x minus 2y. 5x minus 2y. 5x minus 2y. In the second parentheses, we have 2x plus y. 2x plus y. And double check answer. Next, solving equation. Okay. Shortcut. Because the left side of the equation is a quadratic trinomial with a leading coefficient 1. Right hand side 0, right side 0, left side. Let's do shortcut. X squared minus 3x minus 40. We need to find the two integers, multiply to negative 40, add up to negative 3. The two numbers must have opposite sign, and negative number has bigger absolute value. So let's see, how do we factor 40? 1 times 40, 2 times 20. 3 doesn't work. 4 times 10. 5 times 8. You would see, actually, it's 5 times 8, right? 6 doesn't work. 7 doesn't work. 8 already have it. And remember, the negative number has a bigger absolute value. This is negative, this is positive. They do not add up to negative 3. They do not add up to negative 3. They do not add up to negative 3. This one, yes. Positive 5, negative 8. They multiply to negative 40, add up to negative 3. Awesome. Thank you, Amanda. And look at this red number. Its opposite is negative 5. And look at this Look at this red number. Its opposite is positive 5. You don't have to enter plus 5, just 8. Sorry, my bad. Negative 8, its opposite is positive 8. I start to lose it now, right? Okay, so Positive 5 opposite negative 5. Negative a opposite is positive a. So the answer is negative 5, comma 8. Negative 5, comma 8. Negative 5, comma 8. And you can always double check by plugging in the values. The values must satisfy the equation. You have a calculator. Next. It's a word problem, right? Let me copy paste. Oh. Do it again. There are, oh, shaking hands. I remember this problem. I think very likely because it appears in, I think I saw this problem on the exam 3 review, and it appears again. I still remember. So the function is given h equals 0.5 times n squared minus n. We have two variables in the equation. The equation actually represents a function, but you don't have to worry about that. So in this equation, we have two variables. H is the number of handshakes. N is the total number of people in the party. We need to find handshakes will take place. Yeah, how many handshakes will take place? So we are looking for H. In order to know the value of H, we have to know the value of N. Is the value of N given? Let's see. He invited 14 friends, including Barry, 15. So N is 15. Then just plugging in, right? So you have 0.5 here. You have 15 squared minus 15. You know, let me show you a trick. If you don't want to calculate the 15 squared, in case you don't have a calculator, right? If you don't want to calculate the 15 squared, you can do this. 15 squared minus 15, you can factor 15 out, and then 15 minus 1. You can double check we factor 15 out correctly. 15 times 15, 15 squared, 15 times 1, negative 1, negative 15, right? And then in the parentheses, we have 15 minus 1, that is 14. You do have to multiply 15 by 14. So this is 60, 15, 0, 2, 10. Yeah, so probably basic, probably similar calculation work. 15 times 15, 225, right? Minus 15, you also have 210. Oh, this is actually easier. Do not worry about that. Forget it. Just want to play with it a little bit. So 225 minus 15, 210. 0.5 times 210 means we have 210. We're divided 210 by 2. 105. 105. That many handshakes. 105. So let's submit. Remember we 17. We did not. I did not say that. So we're gonna lose 1 point from that. $17 here. What else? Oh, we get everything else correct. And if you review the test, can you find like half of them? You can like definitely get it done. And this one is to distribute it properly, right? This is 1. You can do that. This is basic 2. 1, 2, Yeah, this is easy. 3, 4. You definitely can find at least half of them are very basic. Of course, I don't want you just get a 50%. I want you to get it as high as possible, right? Well, it's 7:23. We're gonna do questions and answers the rest of the time. You have any questions, guys? No? Okay, it's fine. If you have any questions, you can stay and ask. If you don't, I would say good luck. You can email me anytime. Just feel free to reach out. I would say good luck to your final and have a great summer break. If you have time, you can stay. I mean, if you have questions, you can stay.
I have questions about the time frame of the testing.
Yeah.
I have to work during the week, and I normally take the test on Saturdays. Can I take the final early on Saturday, or do I have to wait during the time frame?
That's a very good question. If you can only make it Saturday, and you should take it the coming Saturday, can you
Okay.
email me? I will have to do the paperwork for you to take the final
Okay.
on
Yeah, I
Saturday.
will email you tonight.
Okay,
Okay. Thank you.
no problem.
Bye bye.
I don't have any questions. Thank you. I've learned a lot from this class. Oh, that's good. I'm happy to know that. Thank you, Amanda. You have a great summer break as well. Good night. Have a good night, Belle.